deep learning model, which is the MNIST Digit classification. This is the very basic of deep learning. If you are not familiar with what deep learning is, I'll prefer you to go and learn a bit about machine learning first and then come to deep learning. So let's get started. So we'll be importing all the necessary libraries here. Pandas basically is used for data manipulation. This will be a library used for storing the data in tabular manner and performing operations on it based on a tabular manner. As means like import this module in this with this alias. So pandas could be also written as pd, and matplotlib.iplot could be written as plt. Similarly with numpy it could be imported as np and tensorflow as tf. So matplotlib will be basically used to show the images on the computer, while numpy will be used to perform mathematical operations on the values which we'll be having, and TensorFlow will be used as a deep learning library. TensorFlow is very famous in the deep learning community. This will be basically used to run the model and make the model so that we can run it. Cool. So we'll load the dataset. We'll be taking the MNIST dataset. This will be a digit classification problem. Here we'll be classifying the digits from the images. So the digit range would be 0 to 9, and this is a very basic problem which is mentioned, which is like a hello world of the deep learning community. So we'll be importing this dataset into the MNIST variable. Now we'll be doing a train test split. So not a train test split, but dividing the data into two parts so that we can store it accordingly. So basically we'll be using mnist.load data and storing it in xtrain and xtest and ytrain and ytest. So basically this is the different points, and this will be the name of the the value of the number. So this is basically it, and you'll load it into xtest and ytest and xtrain and ytrain. Now the train test split procedure is to estimate performance. As I said, we'll be using to divide it into two parts so that we will be able to test it easily. Now we'll be just looking at the shape of the model. So this would be the shape. This is 60,000 samples with 20 into 28 size, so 28 and 28 pixels. Now we'll be doing plt.imshow. This is the 111th example, so we're just running it and showing it like this. So we can see this model right here. We can see this image right here. And then you're going for x_train 1.shape. So basically this is the shape of the first sample, which is 20 and 28. When you look at the first sample, this would be a collection of 2D arrays because this will have the numbers in them. And now since this will be a black and white image, because MNIST, when you process a black and white image, it has one channel, and when you have a colored image, it has generally three channels: RGB, red, green, blue. In OpenCV it is BGR. So that's the point here. So we'll be using a black and white image because the data which we loaded in has this kind of feature. So basically this is a two-dimensional. That means the data will be in two dimensions. These are the values. So what does these values mean? These values are the values of the brightness. 0 means black, and the upper end, which is 255, means white. So these are the two values. So 0 is the lower end and 255 is the brighter end. So we'll be having the values in between these two values. So basically you will be having every value between 0 to 255. So this is the image present in the form of a matrix. Now normalizing the values. Why do we do this? Because we want to make the calculations faster for the computer, as well as make them more accurate. This will actually help us to perform the test easily in a way better manner. So that's it. And now we're going to build the model. We'll be using TensorFlow, which is our library for building deep learning models. So keras.models.sequential. Sequential is a model in which layers are connected one by one. So 1, 2, 3, 4, 5 like this. Flatten will be basically for flattening the input. So this is the first layer. So this set flattens the input, does not affect the batch size. Now the input shape will be 20 and 28, which will be the size of the images. Now dense 128, dense layer will have 128 neurons with the dimension function of ReLU. So ReLU stands for rectifiable linear unit, and this is a new function which came into existence. Earlier we used to use sigmoid, but ReLU is much better than sigmoid, as due to various reasons. We can cover that in another video, but ReLU is really a great way to go for models. Like most of the models would use ReLU, like on a very basic level. Now again we end up with 10 nodes in the last layer. Why? Because 10 nodes signify 10 digits, 0 to 9. So we'll be having this. Now loss function, so we'll be just like running this also. Model, everything ran perfectly. Loss function equal to TF k rest losses pass categorical cross entropy. This is the function. So if you can hover, this is why I use Colab. So if you can hover under this, you can read the whole description. So you can read about this. This is basically a loss function. Loss function means to just minimize the errors and to evaluate a model. This also ran perfectly. We'll compile a model with using the optimizer Adam. Adam is again an algorithm, which is again a great algorithm. You can search it up on the net because this is a very deep topic. Now loss function, I have told you, this is again used to measure the loss. We'll be using this loss function and optimizer this. Our metrics will be accuracy. So we'll be fitting the model. Now we'll be using, so you can see these are epochs. Epochs is basically a number of times you are running the model on a data set. So 185, 1875, 1875, these are the number of times the model is, number of the parts or the number of times it is running. So 5 times the model is being running. After the 5th time it will stop running. This is the time and this is the loss. So at the end of the time we have very low loss and very high accuracy. So we'll be checking our model on the unchained data. So unchained data is the data which we split at the beginning, X test and Y test. So let's run this. So 97% is pretty good. Now I'll be using another library called OpenCV. Now OpenCV is imported as CV2, so don't get confused. We'll just import CV2. We'll be creating a function called def get image path printer equal to true. This is just a simple function to print the image. So and basically we'll be reading the image and reading as a grayscale image. So printing as original dimensions, original image dot shape is the first shape of the image. Resized, this is the original image, and then this is your pixels. So we'll be resizing it in 20 and 28 pixels, which was same as our original image. Basically we are now texting the new images, so you can place any image over here, but in the data set which we were using earlier, we're using 28 and 28 size images. So that's why I'll be sticking to it, and we'll be using print resize dimensions, resize image shape. So basically we'll be resizing that image and treating it as a grayscale image so that we can treat it as the same data which we had earlier. Now image path equal to content test 3.png. Basically I downloaded an image earlier and I can show you. I have opened it on the tab. This is the image we'll be going to use. So on Colab you can just click on the folder and then drag and drop over here and you'll get the image over here. Click on the 3 dot, copy path, and then paste the path over here, so you'll get this. So I think this would be correct. Now I'll use this function, pass the image path into this function. Just give me 1 minute and I'll just pass this here. Getting an error. Oh, sorry, I didn't run this function first. Okay, now this should run. This ran perfectly. I'm getting PL2. I'm sure resize image. This is the image we're getting. This was the original dimension of the image. Of this image, get it as grayscale image and showing as 28 and 30. You might be worried why is it going in this color while I use this colored image. Basically it reads image in the BGR format instead of the RGB format, and due to that basically we'll be getting a different colored image. Now this is the resize image. So the resize image will be just expanding the dimensions. Basically we'll be just trying to show you, I'm just trying to show you this is the image, and we'll be just showing you that this is the image. The count is 1, and like this one channel because it's black and white in color, so it will be 1 on the first side and then 20 and 20 on the other 2 dimensions, which means that this is the number of samples basically, and this is the size of the image, so 20 and 28 pixels. Now we'll be using the model.predict. We'll be predicting. Our predictions will be stored over here. So what are basically our predictions? Let's first see that. Now as you can see, I think the most value is given to this. No, sorry, this. and this is our 0.23. 3 has 2500 something. That's really huge, and I think this would perform great on our. So we got the answer as 3. Thank you so much. This was the MNIST data classification project, and I hope you learned something. And if you have any doubts, please put down in the comment section. Like and subscribe, and ask your friends to like and share it too, so that it reaches the maximum amount of people who this video could help. Thank you so much. I hope you like the video. Please mention if you have any comments or anything in the chat section, in the comment section. I'd really love to hear your feedback. Thank you.